All right, good morning. Thank you for joining this webinar about hydrogen, building a resilient and decarbonized energy system. My name is Patrick Kools. I'm the Director for Clean Energy Projects in Europe for Yokogawa. And before I want to move on, I really want to thank you for joining in this webinar. There have been over 100 registrations from all over Europe and all over the world. So we're really, really pleased that you found some time to come and listen to us today. So thank you for registering, and also to our partners for sharing the word. It's been awesome how everybody's been talking about this. Before I start, a little bit about myself. So my name is Patrick Kools. I started my career at Shell. And after that, I've always worked at the interface of large projects in industry, digitization, and change management. And I was responsible, for example, for designing the IT strategy for the Groningen gas field, the big gas field here in the north of the Netherlands in the 90s. And that's been a lighthouse project in terms of automation for Shell for the past 20 years. And more recently, before the current terrible situation in Ukraine, I spent 4 years delivering a large project to the Russian Arctic Circle. Now, I've been involved in hydrogen for the past 5 years, and initially mainly in studies, getting to understand what hydrogen is about and its role more deeply. And more recently, we are actually, and my team is actually getting involved in actual projects, and we hope to tell you something about that today as well. Now let me see, get a little setup. My goal for this webinar is that, we hope to share some of our learnings. So I would like to give you a fresh perspective on how the world is developing and how the energy transition is developing. And also how hydrogen is playing a small but very important role in that. And maybe I open up some new ideas how digitization actually can contribute to a more fair and a more democratic and more efficient energy ecosystems. And I also hope that we'll have some fun. I mean, this is going to be a broad talk, so it's not a deep technical talk that we're talking about. And let's play together and let's learn together. If you have any questions, you should be able to put that into the panel. And my colleague Oana, who is also on the line, she will pick those up. And at the end of the session, she will pass the questions on to me, and we can, hopefully we can answer those at that moment in time. Okay, so let's go, and we hope to finish at about 10:45. So let's see if we can stick to that timing. I think that would be great for everyone. And I must say, this format is it's a bit challenging because normally you talk directly to people, but now in a webinar, of course, you don't see anyone. So I hope you're all actively sitting there with your coffee. Now, some quick facts about Yokogawa. We are an industrial automation company. And of course, over the past decade or so, automation has become more and more a central aspect of all industrial activity. As the world is digitizing more and more, and these really are exciting times. Now, Yokogawa is a globally operating company. We're very purpose-driven. What I like about, the Japanese business is that once they decide something, they really mean it. And for Yokogawa, contributing to the energy transition and to a sustainable planet really is a core aspect of our overall strategy. And that shows in our commitment, going from our founding principles to the core values and also the goals that we are pursuing. We're about 109 years old, 17,000 employees all over the world, and I'm based in Europe. And again, I'm responsible for the clean energy projects that we're doing in Europe. Now, recently, or actually about a year ago, we also became an active member of the Energy Transition Campus in Amsterdam. This is actually the Shell Research Center that has opened up to become a collaboration campus of many different companies working on the energy transition. So it's now no longer Shell itself, it's actually become a standalone entity with Shell also there, but many other parties working together. And we are hoping there to help accelerate the energy transition by demonstrating new enabling technologies and also to work together with these partners. And working together is, I think, also a central theme of this whole webinar. So let's dive into it. The first part that I want to talk about is, I want to give my and our perspective on how the world is actually developing in terms of energy and the energy transition, and what key drivers are actually moving the direction that we're going into at the moment, with the whole world and definitely in Europe. So some key drivers here, of course, at the moment, top of mind is the terrible situation that's taking place in Ukraine, which is from a human perspective disastrous, but also has a huge effect on energy and the whole energy transition. Then, of course, we see the environmental issues coming up more and more with floods and droughts happening and forest fires and such. And at the same time, we've just gone through winter where there's been extreme energy pricing. And, that has also indicated how, the access of free and or affordable and reliable energy is not just a given. We're maybe in Europe especially very spoiled that we've always had access to very reliable and relatively cheap energy. And we've now been understanding that that's not always the case. And I think these three events are a good reflection of what the World Energy Council calls the energy trilemma. And it says when you're looking at energy, there's really three issues that need to be kept in balance. And one of them, of course, is the environmental sustainability. How is our energy system impacting our environment? But we're also looking at energy security. Again, can we maintain access to the energy that we need to run our society? But also energy equity. And it's interesting here in the Netherlands, it wasn't always such a big thing, but we're now really seeing that, there are many people that are not getting affordable energy. But if you take that a bit wider and you look at the planet, there's still many, many people that do not have access to the power system or to reliable energy. So that's a big issue that we need to solve with each other. Now, and with the intensity of the war and the effect on pricing, the risk is that the environmental issue is being pushed to the back a little bit. But if we look at that, I just want to point out that also our planet is a very big system. And the picture that I'm showing here is one that was actually shown on COP26 last year, and it shows that on the Earth, there are actually a number of very vulnerable tipping points in our whole climate system, like, for example, the Arctic sea ice or the temperature of the oceans or the Amazon rainforest. And the concern is that if we, if the CO2 emissions keep going and the average temperature in our planet rises, that these systems may well be disturbed in such a way that we reach a point of no return. And once one of these systems starts changing, they also start affecting other systems. So once the Arctic sea ice gets below a certain level, it might have an effect on the borealis forest in the north of Russia, and that might have an effect on other areas as well. And if you think, well, this is a long way off, I'm not sure whether any of you have seen a picture like this come along over the past few weeks, whereby we see that, this blue band here are the average temperatures, the sea surface temperatures of the North Atlantic since 1982. And the red line is the average sea temperature at this moment in time. And I'm not a statistician or a process quality expert, but I don't think you need to be an expert to sort of see, hey, this is quite an outlier and what's going on here. So there is a lot happening in the environment also. So we really, have a big challenge there as a society. Taking this a little bit further, And you might think, hey, yeah, but you know, if I follow the news, and definitely in Europe, if you follow the news, you might think, oh, but we're already doing so much about the environment, and there's a lot of projects starting up. But really, this is no time to rest, because if you look over the past 20 years, we actually see that the carbon intensity, that means the emissions of carbon in the world, have actually declined quite slowly over the past few years. And in 2021, they only declined by 0.5%. And to be honest, to limit global warming to 1.5 degrees, we need to achieve a 77% reduction in carbon intensity by the end of this decade. So that's by the end of 2030. Yeah, and that's 6.5 years from now. And this means that we need to decarbonize by 15.2% per year. And that is 11 times faster than the global average achieves over the past 2 decades. So if you think, hey, you know, over the last 5 to 10 years, I've been hearing a lot about decarbonization, and, you know, I'm about done with it. You know, I want to do something else. The news is we need to speed up. And I think the good news is that over these past 10 years, a lot of preparations have been made. And I think a lot of resources are now being focused in this direction. And that is something I want to talk about briefly as well. Because what we see in Europe is that also as a response to the situation in Ukraine, there's been a large focus on the energy security, and specifically cutting Europe's dependency on Russian gas. And at the same time, we already had a program in place called Fit for 55, which was focused on reducing our CO2 emissions by 55%. And these programs are really getting together now. So there is a huge focus from the European Union on renewables, putting more rooftop solar, decarbonizing industry, speeding up the permitting for renewable energy as well. And within that, and that is the topic that we're talking about more today, there's also been a very strong focus on hydrogen. There was already an ambitious target. I'll get back to that in a second. But as a result of the Ukrainian situation, that target that was already extremely ambitious has been doubled. So we have a lot of work ahead of us. Just let me grab a sip of water for a second. All right, thank you very much. And to just point out how big the task is that we have, and hey, you might be thinking, which direction is it going? But you know, I just want to make clear that how big the challenge is, and what it is that we have ahead of us coming up the coming few years. Just to get an idea of how big the task is that this RePower Europe, it's about changing our energy system. And if you look at the energy system in 2016, you know, this is not so long ago, you can see here the sources that we were relying on were oil and natural gas and coal. And these are like the users for our transport and aviation and our manufacturing and our buildings as well. And if you fast forward to the projections to 2050, and you know, this is just a global overview, but it does give you an impression of how big a change we are actually talking about. Yeah, we are talking about making a big change in the sources of energy that we are looking at. So moving away from oil, and of course, natural gas will still play a role, but away from coal specifically. And you see here a huge stream of different energy sources coming in. So that is a massive change that we're bringing into the whole system. And you're also beginning to see that we're increasingly hoping to rely and changing also the type of energies that we want to use in the end users, specifically with a big role for electricity as well. And interestingly enough, when you look at this picture, and today we're talking about hydrogen, hydrogen actually in terms of volume only plays a very small role. So, you know, that's like a double message. I think that in Europe, we've been seeing a lot of announcements about hydrogen projects and hydrogen activity, and a lot of ministers putting a lot of effort on that. But that is only a small part of that is really happening. So we got to keep in mind on that too. But if we zoom in on this, and if you zoom in, things get bigger again. You know, hydrogen in itself is not a new thing. Already at this moment in the world, there is a lot of hydrogen being produced, and it's actually non-decarbonized hydrogen, usually produced from steam methane reforming. And the current use of hydrogen, which is mainly as a feedstock for refineries, for example, the current production of hydrogen is actually one of the bigger emitters in the world. Yeah, at the moment, the production of hydrogen emits about, in 2018, 830 megatons of hydrogen, of CO2 every year. And that's 2.2% of global emissions. And yesterday I learned that's actually about equivalent to the emissions caused by our container shipping industry, which does about 3%. So at this moment in time, although hydrogen is being seen as, a way out, a green solution in the energy transition, at this moment in time, much of the production of hydrogen actually contributes to the CO2 emissions. So we have a problem to solve in the hydrogen production itself, and then we also need to make a shift to alternative use of hydrogen. So that brings up the picture where we are going to. So what you're seeing in 2050, the ambition is to have much more clean hydrogen available. So we want to make this shift from at the top, some non-decarbonized hydrogen probably is still going to be around, but we want to make a shift to a much, much larger volume of low carbon or renewable hydrogen, either being made from natural gas with CCS, so that, the carbon is captured and stored safely, or via solar and wind power and electrolysis, and either grid connected or in other ways to create clean hydrogen. So there's a shift in the production of hydrogen, there's a shift in the volume of hydrogen, but there's also a shift in the applications of hydrogen. So we're looking to decarbonize the current hydrogen delivery, but we're also seeing whether we can use hydrogen as an energy carrier, and also as a feedstock for chemical processes, and also, and this is a big focus here in the Netherlands at the moment with our Tata Steel, whether we can use hydrogen actually to clean up the production of steel through the DRI, the direct reduced iron process. And that is a big challenge at this moment in time. Let me just take one more sip of water. Alrighty, so many shifts happening at the same time. So moving away from non-decarbonized hydrogen to decarbonized hydrogen, moving away to larger volumes of hydrogen, and actually moving in the direction of different uses of hydrogen, as for energy, for feedstock, and for specific industrial applications as well. So if you add all that together, and then see what the challenge is that we have in the hydrogen space, you can actually see that, there are huge ambitions in terms of ramping up the production volume of hydrogen. And what I found here, I was actually looking for a good graph of the actual updated RePower Europe volumes, because remember, those doubled, but I found a graph that actually represented the initial Fit for 55 target, which was producing 5.6 million tons of hydrogen in 2030, clean hydrogen. That target was actually there, but now, that has actually been increased to 20 megatons of production of clean hydrogen, of which 10 megatons needs to be produced in Europe alone. And if you put that on a graph, you see that actually the installed capacity that we need to create there for clean hydrogen actually is more than 100 gigawatts of clean hydrogen production. So 100 gigawatts of In my mind, that's 100 gigawatt of green electrolyzers producing about 10 million tons of clean hydrogen in 2030. Imagine that, that's in 6 years' time. So, and really feel into that number, yeah, because if you think we're already doing a lot, at this moment in time in Europe, we have 20 megawatts is the biggest installation in Spain that's up and running. So we have 20 megawatts up and running, and the ambition for hydrogen, green hydrogen production in Europe is 100 gigawatts. Yeah, that is 5,000 times the current installed production volume. Yeah, and if we look in the Netherlands, for example, I made it very small here, but in the Netherlands, the ambition by 2030 is to have 8 gigawatts up and running. So, and again, in Europe, we have 20 megawatts running at this moment in time. That is up and running and actually producing. And to be honest, it's not even producing full time because, you know, it's connected to a solar grid. So, you know, it's producing a number of sun hours. It's in Spain, but the numbers are, you know, I've been thinking about this for the last couple of weeks. The numbers really are mind-boggling. So if there are any colleagues here from the, you know, digital automation side, or, you know, clients here that are thinking about joining the hydrogen space and thinking there's not going to be enough work for the coming decade, look at these numbers. Yeah, it's huge. The challenge is very big. And I keep thinking, you know, how are we going to do this in a good way together and learn quickly? Now, the commitment of the European Union and also of the financial industry to enabling this transition is also huge. Yeah. So in terms of money, there's 503 billion has actually been reserved for climate and environmental investments. And if you look at that in the RePower plan, there's an additional investment of 210 billion for phasing out Russian fuel imports. But if you look at hydrogen specifically, there's been a reservation made of 5.2 billion via the IPCEI program to kickstart the hydrogen development. And if I look at the Netherlands, for example, specifically, there was about, you know, a billion, I think it was about a billion, no, $1.5 billion, that was taken out of this IPCEI fund, and that was actually funneled into several hydrogen developments. And the biggest one here, which is about 700 million, was actually recently awarded to 7 of the larger hydrogen projects that are now either having taken FID, like the Holland hydrogen project, or are about to take FID, like, for example, the high CC projects that are developing and a few other ones. So what I have been seeing is that although we don't see many projects coming onto the market yet, you can see that a lot of groundwork has been done and a lot of energy is being channeled in the direction of making this happen. And just to add to that, and this is the large part about last slide about what is happening in Europe, just this week, the European Council has actually agreed on an update to the Renewable Energy Directive, and that actually is going to set binding targets to reducing emission also for industry. And it includes a target for more than 42% of hydrogen being used by the industry to be renewable. And renewable is as defined by Europe, and that's a whole discussion by itself. And that will rise to 60 by 2035. Now, of course, whether this is going to be ratified, we don't know yet. It's still in process. But what you can see is that, you know, there's a lot of money being made available, but there is also going to be binding targets for this to happen. So will the hydrogen economy break through? Will this whole process happen? It's still exciting, and we're waiting for the projects to come up, but there's a lot of factors actually going in that direction at this moment in time. Okay, so what's the role of digital in all of this, you might say? Yeah, how does a party like a Yokogawa or someone else play a role in this, and this is not just Yokogawa, this is all of us. To explain that, I want to make a little sidestep into how Yokogawa is looking at this total energy system. And I'm going to show you a picture which is wild, but it comes from a white paper that I recommend you to download from our side. But it shows, we call it the energy mandala. It shows how Yokogawa looks at how the whole energy system is actually developing as a whole. And what we are beginning to see, we call that energy systems convergence, is that we believe that we are moving towards an energy system that's going to have endless supply. So in the end, if we install enough solar panels and wind farms and all these sort of things, and it's inevitable, we're going to be producing a lot of energy on the supply side. So the role of the energy system is actually going to change in that it will need to provide answers to how can we distribute that energy that might be produced centrally somewhere. How can we store it to make sure it's available at the right time? And how can we transform it to make sure this energy is available in the right form? Because, for example, not everybody can use electricity for all their processes, and hydrogen is not applicable for everything either. So the energy system is going to be about distribution, about storage, and about conversion of energy. And what we also see happening is that in the old days, we had a linear system where we had a lot of oil and big refineries, and then it all moved downstream. But we're beginning to see that, the plants are getting smaller. They're getting more distributed. We see all our clients, planning for multiple plants all over Europe. And we also see that there's going to be a blurring of the lines between industry and society. Yeah, we see smaller plants being closer to site. We see local production of solar energy, of wind energy. So the whole system is becoming more interdependent and much more connected. What we are also seeing is that although we live in a world where usually companies are very focused on optimizing their own plant and applying all sorts of technologies to that, we're also seeing that they're reaching the limits of that, and increasingly we are finding that customers are approaching us to have discussions about how they can integrate with actually neighboring plants, neighboring companies, and start sharing information between them and start operating together so that they can get more efficient and reduce their CO2 consumptions together. So the way Yokogawa looks at how we can actually accelerate and bring ourselves to a decarbonized society is that we believe, and this is where digital plays a big role, is that we can help with the optimization of individual factories, making them run very effective and very efficient. But we can also help by connecting different plants together and different companies together and helping them balance their energy uses and their CO2 uses and their material uses together, creating a circular economy and thereby reaching a higher level of efficiency. So the direction that we see things going is that we are going to see more and more smart factories that can operate very efficiently, very effectively, and very safely by themselves. And we see more interconnected ecosystems where these different factories are connected together, sharing materials, optimizing energy together, and optimizing their emissions and reducing their emissions over time. And we call this what we call a systems of systems world, whereby we see that everything is going to be interconnected in quite complicated ways. So no longer just linear supply chains, but plants connected together, sharing information and sharing resources, and achieving a level of efficiency and effectiveness that cannot be achieved by one single plant alone. And I just want to give you an example of a project that we're doing really in life at this moment in time. We call this the GOI project internally, and it actually is playing out in Tokyo Bay in Japan. And this is a picture of the area where it is. And in this area, There are about 10 plants ranging from a steel plant and refinery to a chemical plant and a quicklime plant. And they're also exploring the potential for a CCS with CO2 storage. And what Yokogawa is actually doing at this moment in time is to work very actively together with all of these 10 plants, together with NEMO in Japan, a government institution. And what we are exploring is what would happen if these 10 plants here together would be able to start sharing information together about the material usage, about their energy uses, about their CO2 usage, about all the other facilities and utilities that they're using. And what would actually happen if we share that data and start looking at optimization potential between these 10 different plants? What would actually happen there? And what we are finding is in the initial stage, just through the analysis, but now increasingly we are looking how we can make this truly work. What we are finding is that we can actually really achieve significant benefits in energy consumption and also in CCU opportunities if we start integrating between these different companies and they start more working collaborative together rather than just working by themselves. And that leads to very interesting business models, because what you see is that if you start collaborating like that, it might well be that a few plants start operating in a better way, and a few plants actually need to, use their utilities more intensively, so their energy consumption goes up. But as a whole, they actually are able to reduce their energy consumption and their CO2 emissions, and that actually, as a whole, benefits society. So we are exploring this project together with them, and it is a very exciting direction. And this is where you see where digitization is key, because this can actually not take place without having data available from the different companies and without sharing that data in a trusted and a secure manner, and having very clever technologies in order to optimize that between them. Now, another way how we are applying this is in, for example, locally, the Holland Hydrogen Project, this type of thinking. Yokogawa was very honored to be awarded the role as the main automation contractor for the Holland Hydrogen 1 project. And this project, it's actually, I wrote down 150 megawatt here, but it's actually a 200 megawatt electrolysis-based hydrogen plant that's going to be built here in the Netherlands. And at the moment, it's the largest hydrogen plant that's actually taken FID and in which we're actually doing work at this moment in time. And Yokogawa was selected as a MAC in which we play integrator for the whole package. But we're also applying the thinking that I've been telling you about here, because this plant will initially be designed for just one operator, running one operator in the control room and one in the field. But of course, the aim is also in the future to run this plant centrally controlled. There's going to be more Holland Hydrogens coming up. And we also see this as a blueprint for the future Shell green hydrogen plants. And to be honest, we think this is also going to be a blueprint for many of the other hydrogen plants also being developed by other companies in the world. And apart from having a strong focus on, of course, optimizing this plant inside the battery limits, we are also thinking very closely about how can we apply an open digital architecture that's still very secure, that allows us to not just do vertical integration and horizontal integration, but to make sure that this plant is scalable and expandable and we can replicate it very easily. And some core elements of our automation thinking here is to base everything on a central edge server that allows us to control the plant, but that also allows us to bring the data up out of the plant in a safe and secure manner, integrating it with the business, but also making that available for integration with, for example, the upstream wind farm that is feeding this plant and the downstream clients that are actually using the hydrogen that is here, and maybe also the storage systems that are going to be developing around it. And a very important focus of our whole development here is that we are trying to base this as much as possible on open standards. And this is a key message that I would like to give. You know, we are standing for a huge challenge together as an industry. And we are going to be rewiring the energy system in the world. And I think that we are challenged to apply as many open standards as we can, because we need to be able to share data between the different plants, and we need to be able to optimize the whole energy system together. So just focusing on the integration. So horizontally, we are looking to enable collection of all processes and operational data, supporting a variety of industry standard open interface and communication protocols. And we want to be able to integrate equipment, systems, and devices. And this is important because, for example, we see that there are different vendors on the electrolysis side, there are different vendors on the subsystems that are being developed for these plants. And, you know, if we look at the number of plants that need to be built over the coming 6 to 8 years, I think all players are going to be needed. And, you know, we cannot just standardize on one vendor alone. So all the vendors will play a role, but we need to make sure that we can integrate all these packages together. So standards, again, are very important. And in terms of the vertical integration, we want to make sure that the data that we get out of these plants is easily integrated into data lakes, and that we can use that for things like AI, machine learning, remote maintenance, asset optimization, etc., etc., etc. Now, we are applying the same sort of thinking to the Yuri project, which is taking place in Australia at this moment in time. This is a project where renewable hydrogen is developed next to an ammonia plant, and we are applying the same sort of thinking to that renewable hydrogen plant, so as to also enable the communication between the hydrogen plant and the ammonia plant taking place in a very easy way, so that we can optimize across these two plants together. So message is, we are looking very much at vertical IT/OT integration within these plants, making sure that all the data from all the subsystems is collected in an open and easily accessible way, and that it can be made available in an industrial cloud for further integration. And it's strongly our belief that if we work in that way, we enable, again, all these plants to integrate together, to share data, and we enable optimization to be carried out across ecosystems of different plants. And we believe that this will not only lead to efficient, safe, and secure individual plants, but it will also lead to a massive efficiency and productivity gain across ecosystems, across industrial clusters, across industrial activity. And, you know, I once said, I believe it's going to be up to 20%. And, you know, we can have a discussion about this, whether it's going to be more or less than that. But we believe that horizontal integration will bring a big benefit to society in the future. Just to show that in a graph, you know, we've been modeling out, as an example, this is a display that actually showed the production profile of an electrolyzer. And maybe if you look at an electrolyzer standalone and you're supplying to an ammonia plant, you might want to say, hey, I want to have a flat production curve because that's the most efficient way of working. But if you then look at the power costs, you know, because you have renewable power actually coming in, and you have a production and thereby cost profile of your electrical power coming into that plant, you know, you might want to make a different decision. So you might want to be able to run your plant in a more variable way in order to take advantage of also the cost benefit of green power coming in. So by having all that sort of data available, and by having a view on the ammonia plant, on the storage that's available, on the production profiles of the green wind farm, you are actually then able to optimize the production profiles of the hydrogen plant itself, which is shown here in red, making use of storage and making optimal use of the variable wind power while still meeting your supply demands, supply commitments to the ammonia plant downstream. And this is only in a small area. So this is one hydrogen plant, with the ammonia plant, but the idea is, enabling optimization across multiple plants, which may well be owned by multiple companies. So that brings me to the end of my webinar. Again, we believe very strongly that we're moving into a new energy future, and we believe that energy future is going to be digital. And actually, we believe it's going to be digital first, because we think that end customers need to start thinking not about, hey, I'm going to build a plant, and oh, by the way, I need some digitization or some process control on that. But I think they really should start thinking about, what is my business model? How does digital play a role in that? And how can I make sure that the assets that I'm going to build can play an effective role in that digital business model? So the energy future will be digital, and it will be digital first. And then here's my invite to all of you. I believe very strongly that, if all the plans that are now lined up are going to work, we are not going to know what's going to hit us with all the work that's coming towards us in the coming decade. I think it's going to be huge. And, rather than just looking at our own part of the pie, let's work together and keep our eye on the prize. What we want to achieve is clean, secure energy for all. Yeah, and we need to scale fast, but we want to make sure that when we are ready in 10 years' time, that we have an energy system with safe, secure, but interoperable assets that can work together and share data. And what we need for that are really clean architectures, and we believe that the use of standards is very essential. And also, please, let's keep making progress. There are many demands and many challenges and many ideas, but the planet and everybody needs it, that we start cleaning up our environment. So let's start making progress. Thank you for listening to me. I hope that I've been able to give you some new insights. If you have questions later on, you can always contact me. My email address is patrick.kools@yokogawa.com, and we will answer the questions to you directly. So again, I would like to thank you very much for your attention, and hope to see you soon, and let's work together. Goodbye.